Alright, so continuing on with rational expressions, we know that rational expressions are basically fractions. They're going to have a numerator, which is one polynomial, and they're going to have a denominator, which is another polynomial, and the denominator can never be 0, or else you'd be dividing by 0. Now in each one of these, you want to make sure that you factor first, and then you cancel out common factors that are on the top and the bottom. So looking at this first one, I don't need to factor anything because everything is already factored for me. I just need to cancel out common factors. Now when I deal with these kinds of problems, I always deal with the coefficients out in front first, and then I deal with the variables later. So with this one, I have a 10 over 25. I know that I can cancel out a 5 from both of those. So if I divide the top by 5, I'm going to get 2. The 25 at the bottom, if I also divide that by 5, I'm going to get 5. So really, this fraction is going to be 2 over 5. Next, I move on to the variables. Now I know that I have 8 x's on top, but I have 5 x's on the bottom. So that means they have 5 x's in common. Usually it's the lowest exponent that gets it. That's how many exponents or variables that they have in common. So if I cancel out all 5 x's at the bottom, then I have to cancel out 5 x's from the top as well. So 8 minus 5, that's going to give me a 3. So I end up with 3 x's on top, but I'm not left with any x's on the bottom. Moving on to the y's, I know that I have 7 y's at the bottom, and I have 3 y's at the top. So if I get rid of all 3 y's at the top, that means I need to also get rid of 3 y's at the bottom. So this 7 is going to be 7 minus 3, which is 4. And then lastly, we look at the z's. I know I have 4 z's at the bottom. I can get rid of all 4 of these z's if I make sure that I get rid of 4 z's at the top. So this 10 is going to change into a 6. So now I've canceled out all that I can, and now I rewrite my expression. So on the top, I'm left with a 2. I'm left with 3 x's. I don't have any y's at the top anymore, so all the y's are going to be at the bottom. But I have 6 z's at the top. Alright, now in the denominator, I'm going to have a 5. I don't have any more x's, so I don't have to worry about that. I have 4 y's at the bottom, so I'm going to have y to the 4th power. And then all these are gone from the bottom, so I'm done. Notice that there's nothing left to cancel out on the top and bottom. That's a good indication that you've got it fully simplified. Okay, so looking at the next problem, I have an x minus 3 on top, and I have an x squared minus 9 at the bottom. Now looking at the top, I can't factor anything up there, but at the bottom, I notice that this is difference of squares. Difference of squares. So what I can do is, I can break this apart into its square roots, right? So at the top, I'm left with x minus 3. But I can put the bottom into x minus 3 and x plus 3. I'm taking the square root of 9 to get 3, and I'm taking the square root of x squared to get x. And whenever I have difference of squares, I'm always going to have a minus and a plus. So now, with the bottom being fully factored, I know that the x minus 3's are going to match up. So I can cancel those out. And then what am I left with at the bottom? Just the x plus 3. What am I left with at the top? Well, nothing, right? So I'm going to put a placeholder 1 in its spot. So if I ever get rid of everything from the top, or if I get rid of everything from the bottom, I'm always going to put a placeholder 1 in its place. So that's rational expressions, and I hope that helps.